it has a greater base area, so the line of action of the weight will be made within the base area. Just now, I think I never talked about this. I just say the larger the base area, the more stable it is. But if they want an explanation, you say the line action of the weight will be made within the base area. Now, look at the Marcus report. They say some candidates simply stated that the bus had a large base, so there was a lot of contact with the ground, and so reduce the pressure or increase the friction. They are not even asking for pressure or friction, right? The wider base area also lower the CG. But they never explain why this improves stability. So the part that we underline when the bus is slightly displaced, line action of the force or the weight will still remain within the base area. This is crucial to get you your 1 mark. So those of you who have marked already, please check whether you have this. If not, then you should not get your 1 mark. Next, with a base made of thicker glass, the center of gravity will be lowered, thus improving its stability. So this slide is just talking about center of gravity being lowered, right? Some look at the Marcus report. Some explain that the stability is improved simply because the weight of the bus increases. So that is wrong, right? Imagine I make the height of thicker, I make the tip thicker. What will happen? It will in fact be more unstable, although the weight is increased. You all know what I mean? I say again, if this is my bus and if I add something on it here at the top, it will make it more unstable. So if I add something below, it will be more stable because it brings down the position of the center of gravity. Then some students say that the glass will become stronger and less likely to break. But that is not actually talking about the stability. It is just talking about the strength of the glass. Okay, so these are some mistakes that students make. Okay, I promise I will upload the answer. Okay. Okay. Huh? I think it should be CENTRE. Okay, so it's the American and the British, doesn't matter. Okay, now look at this, just now who wanted me to go through electricity, better look up. So this is actually a circuit, and you see that the circuit is slightly more complicated than last year's. Okay, how are X and Y arranged? X and Y, they are parallel. So if I were to actually now, which circuit is simpler? After we draw, right, it becomes a very simple series circuit. So you must always identify where are the resistors that we can actually combine more easily. Okay? That have the same current in them, W and Z, that will get you your 1 mark. Same potential difference across them will be X and Y. Because if they are connected in parallel, some symptoms are voltage will be the same. Right? If they are connected in series, current will be the same. Okay? Now, how do we show that the total resistance of the circuit is 15 kilo ohm? So, like we did just now, we should simplify this. So, they are connected in parallel. What is the effective resistance? Will be 2 kilo ohm, right? 1/3 plus 1/6, then whole thing divide. Whole thing invert. Okay? So if it's 2, then this is 7. This is 6. Now you can just add them all together because now they are in series. So you have shown that it is 15 kilo ohm. 2 marks. Calculate the current in resistor W. Okay, So I withdraw everything because W is also part of that line there, right? 12 over 16 ohm. Here will be 12 volts potential. Here will be 0. So I can actually find what is the current that comes out. So it's 12 divided by 15 kilo ohm. So once I get this current, right, I put it back here. And this current will actually travel throughout and go back to the negative terminal. Yes? And that is the current that passes through the 6 kilo ohm, and that will be your answer. And so you should get 5.6 volt because the current flowing through is 0.8 milliampere. Okay?